Circular motion is the result of perpendicular force which is always at 90 degrees to the motion. This force always acts towards the center of the circle. Since this force is perpendicular to the motion, it does not change the speed of object. Instead, always pulls the object toward the center, which keeps the object on a circular path and result in a circular motion. As the object moves in a circular path, it has angular velocity. Angular velocity is the rate of change in angular displacement. Average angular velocity is given by the change in angular position theta 2 minus theta 1 and time duration. The instantaneous angular velocity is the time derivative of angular displacement, and the unit of measure of angular velocity is radians per second, and its direction is the same as the direction of angular displacement. The direction of angular displacement, angular velocity and angular acceleration is given by the right hand thumb rule, and it's always along the axis of rotation. It is positive or negative depending on the anticlockwise or clockwise direction. In case of anticlockwise direction, as in this case, as per right hand thumb rule, the angular displacement or angular velocity is positive in positive z direction. While in the case of clockwise circular motion, as per right hand thumb rule, the angular displacement and angular velocity are in minus z direction along the axis. As an object moves in circular path, its direction of motion keep on change every moment. This change in direction of velocity results in acceleration, which is directed toward the center, and it's known as centripetal acceleration. Understand here, force, acceleration and change in direction of velocity all are interrelated. Force toward the center changes the velocity direction, and this change in velocity results in centripetal acceleration. Its magnitude is given by v square by r. Here v is the speed of tangential velocity, and r is the radius of circle. And this is equivalent to omega square r, where omega is angular speed or angular velocity. Unit of measure of centripetal acceleration is meter per second square. So till now we talked about acceleration, which is related to change in velocity direction. Recall your understanding of velocity. Velocity is a vector quantity. It has direction and magnitude. Change in velocity can be because of change in its direction, change in its magnitude, or change in its magnitude and direction. The rate of change of velocity is acceleration. So in circular motion, the linear acceleration can be because of any of the following reasons. The first one, the change in velocity direction. Because of this, in circular motion, there is a centripetal acceleration. Second, the change in velocity magnitude or change in speed, and the resultant acceleration is tangential acceleration. The third case, there is a change in direction as well as in magnitude. In this case, you have both type of acceleration, centripetal acceleration and tangential acceleration. The resultant will be the net acceleration A. Basically, the centripetal acceleration and tangential accelerations are components, the perpendicular components of net acceleration in circular motion. In circular motion, there is always a change in direction of motion. So there is always centripetal acceleration, even the object moves with constant speed or constant angular velocity. In other words, the circular motion is not possible without centripetal acceleration. In case when speed changes, it creates tangential acceleration. Here, an object is moving with increasing speed. It means the direction of tangential acceleration is same as the direction of tangential velocity. The tangential acceleration is equal to dv by dt, the time derivative of speed or magnitude of velocity. The average tangential acceleration is given by v2 minus v1 divided by the time duration, and its unit of measure is meter per second square. The magnitude of tangential acceleration is related to angular acceleration with the equation at equal to alpha r. Alpha is angular acceleration and r is the radius of circle. In circular motion, the tangential acceleration is always perpendicular to centripetal acceleration. Both these accelerations are perpendicular to each other. The net linear acceleration of circular motion is given by vector sum of centripetal acceleration and tangential acceleration. Here, the magnitude of acceleration, the net acceleration, is a is equal to under root of ac square plus at square. And the direction of net acceleration is given by tan theta equal to at by ac. Here, the theta is the angle between a and ac. Now, it is important to note that in circular motion, the tangential velocity, the tangential, centripetal and net acceleration all are always variable, even if their magnitude are constant. And this is because of these quantities are vector quantities and direction of all of these quantities keep on changing every moment or every instant of time in circular motion. So remember, these vector quantities like velocity, tangential, centripetal, net accelerations are always variable in circular motion irrespective of constant angular speed or constant angular acceleration. Till now we talked about angular velocity and its direction, the centripetal acceleration, the tangential acceleration, net acceleration. These three accelerations are related to linear accelerations. Now get back to the angular quantities. Here the angular acceleration. Angular acceleration is the rate of change in angular velocity. The average angular acceleration is given by omega 2 minus omega 1 divided by time duration. And the unit of measure is radians per second square. The instantaneous angular acceleration is given by d omega by dt, which is a time derivative of angular velocity. The direction of angular acceleration is given by right hand thumb rule. In this case, for anticlockwise direction, omega is in positive z direction. Here, if omega is constant, that means the angular acceleration is 0, since there is no change in angular velocity. The value of the linear velocity, the linear tangential velocity, which is equal to omega r, will also be a constant. That means the object is moving with a constant speed on circular path. What about the tangential acceleration? Tangential acceleration is alpha r. Since alpha is 0, so tangential acceleration will also be 0. But what about the centripetal acceleration? Speed square divided by r. Both these quantities are constant. That's why the magnitude of centripetal acceleration will also be constant. Remember, the centripetal acceleration is a vector quantity and it's always variable in case of circular motion because of continuous change in direction. Okay, but if we talk about the magnitude only, the magnitude will be constant. Now let's consider another case where the omega is increasing, means angular speed is increasing with time. This is the case when the angular acceleration and the angular velocity, both are in same direction. Since in this case the object is moving with increasing angular velocity in anticlockwise direction, that means the direction of omega and alpha both are in positive z direction as per the right hand thumb rule. And that's the reason the angular speed is increasing, or the linear speed of circular motion is increasing with time. Now consider in this case, if alpha is constant, means the rate of increase in angular speed is constant. In this case, the speed of circular motion keep on increase with time. So that means V4 is greater than V3 and V3 greater than V2 and V2 greater than V1. That means the speed keep on changing with time. Because of this, the tangential acceleration, which is nothing but the alpha cross r, the angular acceleration into r, is constant. The magnitude of tangential acceleration is constant. Again, remember the tangential acceleration is a vector quantity. Its direction keep on changing. In this particular case, when we think the alpha is constant, the magnitude of tangential acceleration is constant. But tangential acceleration as a vector quantity is not constant because its direction keep on changing. What about the centripetal acceleration? Centripetal acceleration is speed square divided by r, and as the speed is keep on changing every moment of time, the centripetal acceleration magnitude is also keep on changing. Now let's take the third case where the angular speed or angular velocity is decreasing. The motion is again anticlockwise direction, and here we see the direction of angular velocity is opposite to the direction of angular acceleration. Okay. Or the direction of angular acceleration is opposite to the direction of angular velocity. Because of this, as time passes, the angular velocity is keep on decreasing, or angular speed keep on decreasing. Now in this case also, if we assume that alpha is constant, means the rate of decrease in angular velocity is constant. It means the velocity will reduce from v1 to v2 to v3 to v4. So v1 is greater than v2, v2 greater than v3, and v3 greater than v4. In this case, the tangential acceleration, the magnitude of tangential acceleration is constant because alpha is constant. What about that centripetal acceleration? Is again, as I said, is a variable because as a speed is square divided by r, and speed is keep on changing. In our next video, we will be solving some numerical problems based on today's learning. Now it is a time for 3 conceptual questions. Please try these questions and put your answers and comments in the comments box. Answers to these questions are there in description box. I hope you would have enjoyed today's session. If you think you have learned something new today, then please click like button and subscribe us for similar type of conceptual videos. Thank you for watching. See you next time. Bye.